All right. So I'm going to ask Dr. Cragle to present her screen.
Can you see it?
I can.
Okay, very good. You ready for me to begin?
I am. I'm ready. So go ahead, Donna.
Okay. Good morning. I'm Donna Cragle, and I work at Oak Ridge Institute for Science and Education, which is part of Oak Ridge Associated Universities. And I'm going to talk about the Beryllium Lymphocyte Proliferation test today. And this is a blood test that is used to find people who are having a reaction to beryllium and may be at greater risk of developing chronic beryllium disease. The test itself is listed by the College of American Pathologists as a complex laboratory test. And right now, in the United States, there are really just 2 labs that are doing the test at a fairly high rate of testing. One is National Jewish Health, which you'll hear from Peggy Mroz after me, and the other is our laboratory. There are other labs, maybe one other that is actually doing the test, but not on a particularly commercial basis right now. So I'm just going to walk you through.
Peggy, I'm sorry to interrupt, but could you go into the view and make it a full screen for us? It's up at the top. Hit view and then it'll be a full screen. Yeah. Thank you.
Look at that. Okay, I said it's a complex laboratory test. And so I'm going to walk through the steps of the test to kind of let you know what all is involved. And it's a little bit of an expensive test as well, but I think when you see what's involved, you'll know. So blood samples are drawn at clinics all across the United States and shipped to either the ORISE lab where I work or at National Jewish Health. And it's very important that those blood samples reach the laboratory within 24 hours of being drawn so that the lymphocytes are still viable, because we're going to want them to grow in the laboratory. We can set up a 48-hour sample with the approval of the ordering physician, but we prefer to have blood that is 24 hours or less. So the first thing that we do when we get the blood, which we get about 30 milliliters from each patient, we layer the blood onto a separation medium, and we spin the blood in the centrifuge so that we can separate out the lymphocytes, because that's really what we're going to be using for the test. After we centrifuge the blood for a certain amount of time on this density gradient, the blood will separate into its components, which the top layer you see is the plasma. The middle layer, the opaque layer, is actually where the lymphocytes are found, and the red blood cells go to the bottom of the test tube. And so the technologist will go in and pull the opaque layer out, pull a pipette out all of the lymphocytes that are found in that layer. Once they've done that, then they will wash them to get rid of a lot of extraneous material that may be in the blood, any leftover plasma or anything. So they'll wash them a couple times in saline, so we make sure that we have some really pure lymphocytes. And then they have to resuspend them in saline so that they are at a certain concentration of lymphocytes per milliliter. In order to do that, we have to use a hematology analyzer to let us know what the cell count is in each particular aliquot that we have prepared. And then we either have to add a little bit more saline or take some of the saline off to get the concentration of cells just right to be able to do the test. Once we've done that and gotten our lymphocytes purified, then we will mix them on culture plates. And what you're seeing here is a 96 well microtiter culture plate. And this is like 96 little test tubes on one plate. And so for each person that we are testing, we will fill 12 of those little test tubes with growth media and their lymphocytes. We'll fill 4 with growth media, a beryllium concentration and lymphocytes, 4 with a little higher beryllium concentration, lymphocytes and growth media, and 4 with a little bit higher. So we end up with 4 wells each of 1, 10, and 100 micromolar beryllium mixed with the patient's cells, and then 12 wells with no beryllium whatsoever, because each patient is going to be their own control in terms of what happens to their lymphocytes in this particular culture. So we prepare 2 plates for each patient. One we will incubate for 4 or 6 days, and the other for 5 or 7 days. You can incubate them for any 2 days within that period. So you can do 4 and 6, 5 and 7, 4 and 5, 5 and 6. It's best to have at least 1 day in between the 2 cultures, but it's not a showstopper in terms of actually doing the test. But we do need 2 different days of incubation. And so we will put the plates in the incubator, set it body temperature, and let them go for several days, growing with the growth media that we've put into the wells. After that growth time is completed, we add tritiated thymidine, which is a DNA precursor. Thymidine is a DNA precursor. And so the faster the cells are growing over the incubation period with the thymidine, the more thymidine gets incorporated into the newly developed cells. So as each cell undergoes cell division, there's so much tritiated thymidine around, it will get incorporated into the new cells that are being produced. And so the faster the cells are growing, the more radioactive label gets into the new cells. After allowing that to incubate for a certain period of time, then we draw the samples, the lymphocyte. Before this, we actually lyse the cells in the freezer, and then we draw the samples onto a filter plate so that we can count the beta counts that are coming off the tritiated thymidine that's been incorporated into the new lymphocytes. And we then count this amount of tritium, and we use that to determine if a person is reacting to beryllium. And so generally speaking, if a person's cells that are exposed to beryllium are growing about 2 times or more as fast as the cells, as their control cells, then that means they're having a reaction to beryllium. And finally, a technologist analyzes the data, comparing the cells that were grown in the beryllium-stimulated wells. And also, as the lab director, I review all of the test results as they're prepared. And, excuse me. And so after I have done that evaluation, then the test results go out to the person's personal physician for evaluation, for health evaluation purposes. And I will say that we have been doing the BeLPT since about 1991, and we do about 8,000 to 9,000 tests a year. So that's all I have for right now.
Okay, thanks, Donna. That was a great presentation, and we'll hold for. Does anybody have any quick questions for Donna right now? We want to wait till the end.
Yes.
Mm-hmm. Okay, Dr. Zissel.
Do you also correct for outliers? And if yes, how do you perform this test?
Correct for outliers? You mean in the measurements that we,
yeah,
in the counts?
Yeah, you may have one well with extremely high or extremely low counts.
Yes. We do. We calculate a coefficient of variation for each set of data. And if the coefficient of variation is above a certain level, then we can't use that set of data. But in the control wells, we can remove up to 4 of the outliers and still have a valid test. In the beryllium exposed wells, we can remove only 1 outlier. If it still doesn't come below an acceptable coefficient of variation, then we can't use that test.
What do you regard as acceptable as CV?
Coefficient, well, it depends on the statistical method that you use. Right now, the coefficient of variation that we use for the control wells, I believe, is 1. And for the beryllium stimulated wells, 1.25.
Okay, so Dr. Cullinan?
Thank you. That was very interesting. Can you talk a little bit about overnight samples? They're sent to you frozen, and how much do you lose? Basically, I'm just trying to understand whether we're going to lose a lot by overnight shipping.
Overnight samples are really not a problem unless occasionally, if there is very, very, very bad weather, such as the very bad freezing that we had in Memphis earlier this year, or very hot weather. We do have some problems then, but by and large, the 24-hour overnight shipping does not really cause us to lose very many tests at all, unless the weather is particularly bad.
Sorry, how are you sending?
And I would say we don't ship frozen.
Sorry, I had to mute somebody.
Okay. We don't send frozen samples. We send, once the blood is drawn, it needs to stay at room temperature and not be put into the refrigerator and shipped right away. So that's how the lymphocytes get to us, and they're still living and capable of reproducing.
And do you do any lavage samples?
Yes, we do.
Same technique.
Yeah, but they're actually, National Jewish Health shared with us many, many years ago a methodology for cleaning up the lavage samples before they're shipped that gives them a much higher likelihood of being viable and working in the laboratory after a shipment. But you really want to get them to the nearest lab as fast as you possibly can.
May I have a question, please?
Yes, Lizzie.
The stimulation index is serum dependent. Did you test any batch of fetal calf serum?
It is serum dependent. And so every time we get a new serum in the laboratory, we run a set of 30 unexposed controls, and we calculate what the stimulation index should be for that particular serum. Usually it ends up being somewhere close to 2.
That is plus minus 2 standard deviation or 3 standard deviations? 2 or 3 standard deviations?
I believe we do 3.
3, okay.
It's the Department of Energy metric for doing the BeLPT is pretty specific about how to do those calculations. And Kathy, you might want to send that out.
Right, the guidance document from the DOE on how to perform the LPT.
Yes.
Okay, I will.
That was just redone about 2 years ago, I think.
You know, maybe send it to me just to make sure I have the latest version.
Okay, I'll do that.
Okay, okay. Are there any more questions for Dr. Cragle? Dr. Sissel, did you have your hand up or not?
Okay.
Okay.
Maybe it's a bit a private question or something like that. What do you charge for a single test?
I'm looking at Barbara. She does the, she does the charging here. When we could charge, we were charging about $260 a test.
Okay.
And that's with no profit.
Yeah.
Since our lab is owned by the Department of Energy, we cannot quote compete with the private sector. And so they have required us we can no longer take any commercial contracts unless the Department of Energy blesses them. It's quite a bit of paperwork involved. Basically, we enter into what's called a strategic partnership with a company, and they agree to pay our cost for the test. And our cost is running right about close to $260 per sample. But they have to pay ahead. Basically, we have to keep a little bank account for them, and they draw down against that. Converting everyone to that, it's been the story of my life for the last year and a half. But the only thing, for individual samples, we refer them to National Jewish. I tell everybody, we are the world's most friendly competitors in doing this, but we use the same, we rely on them. We buy tests from them for some of our programs, and in turn, they're very good about referring to us. So it's just a different way of doing business. But when you're looking at, as Donna went through the things, first of all, it is a complex test. You cannot take a technologist right out of school and say, go do this test. When the hospital at the University of Pennsylvania was doing it, they would have their graduate students doing it. And you would see a huge variability in the results as different waves of graduate students came through. You need real experienced technologists. It takes them about 6 months of training in the lab to be fully proficient in all the different stages of it. And then you have the reagents involved, as well as the equipment. We have some equipment that's specially configured just for this test. So it's not cheap.
Okay. Well, we still can ask Dr. Cragle questions after Peggy Mroz's talk, so I'm going to let Peggy go ahead and start sharing her screen, if you would, Peggy.